Hey friends, welcome to the channel. Today in this video we're going to solve the credit problem of week 1 of CS50. So to see the requirements of the credit problem, we'll have to come to this website, which is cs50.harvard.edu/x/2024. If you're watching this video in 25, make sure to change the year, right? Make it 25. And once you're here, once you are on this website, what you will need to do is towards the left you'll need to click on week 1 and then come to the bottom, click on problem set 1, and then I have already made videos about Cas, Mario, Hello It's Me and everything else. So in this week we are going to solve this problem, credit. We'll come down and basically if you read all of this, what you will figure out or what you will know is we have to create a program called credit.c which takes a number, right? It takes a credit card number and it first verifies using an algorithm which is given whether or not the number that is given is valid, and if it's invalid it should give invalid, and if it's valid our program should output the thing, basically the category of credit card that it is, or basically the brand of credit card that it is, whether it's a Visa, a MasterCard or an American Express, right? There also are other other credit cards, but in this program those are the only 3 companies that we are focusing on, and there are 2 very helpful things given to identify that. The first is, like, in the very beginning you will need to verify whether or not the credit card number is valid. Once you have done that, then what you will focus on is the fact that all American Express numbers start with 34 or 37, which is in the beginning it has 34 or 37 and then the rest of the numbers follow. Similarly, MasterCards starts with these particular numbers, and all Visa cards start with the number 4. Okay, and then what you have to focus on is all the American Express cards have a 15-digit number. Similarly, MasterCard has 16-digit number and Visa uses 13-digit and 16-digit. So these are some of the necessary details that you'll have to keep in mind, right? So now let's begin coding, and for that what you will need to do is, in the very beginning, open a new tab, go to cs50.dev, press enter. Once you come here you will have to log in using your GitHub account, so I'll press on login. Okay, once it's loaded, what you will need to do is, in the very beginning, let's go to the folder week 1 that we created previously. So I'll say cd week 1 and I'll say ls. We don't currently have a folder called credit, so I'll make that directory mkdir credit, and then I'll go to that directory cd credit ls. There's no file right now inside this folder week 1 credit. There's no file right now, so we'll create a file called credit.c. To do that I'll say code credit.c, press enter. Okay, and now we are here, we're rolling. So the very first thing that we want to do is we want to include the header files, and we want to create the basic template that we always create in all the programs, right? So for that, very first thing, header files has include cs50.h, similarly has include standard.io.h. Once you've done this, int main void. Okay, so the very first thing that we want to do is we want to take an input from the user. Why is that? Because that's the exact thing, that is how we will know what the input the user has given, and the input should be number and colon. And another thing that you'll notice is the credit card number is very large, right? So I don't think it will be enough to use an integer for this. So what we will use is a long, and it's also mentioned here, it is suggested that we use a long instead of an int, right? So what we will do for that is we will say, let's first declare, and that will be long card. Let's not give a value quite yet. So what we want to do is we want to use a forever loop in a way. We want to assign a certain value to card, and what value is it? We want to use a get long number. Okay, and the condition that we want to use it, while card is less than 0. So if a user enters the value that is less than 0, it will be denied and the user will be re-prompted, right? Number just like this. Okay. Okay, if you see here, if a user enters a number that is less than 0, it will be denied. If a user enters a value that has hyphens in it, which is not allowed, it will be re-prompted, right? Similarly, a string re-prompted, and so on. So once we've done this, the very first thing that we want to do is we want to count the number, right? Basically, we want to count the length of the credit card number. That way, we'll be able to basically see whether or not it is valid using like a very simple logic, right? It won't be super accurate, but it will help us filter. So to do that, I'll declare length, right? And what I want to do is length plus plus. What I also want to do is I want to say long temp card is equals to card. The reason why I'm doing this is I want to preserve the value of card that is entered by the user, because I also want to use the real value for later purposes when I create new logics later on in the program, because this program is going to be pretty long. What I want to do is I want to preserve the value. So I'll create a temporary variable called temp card, which stands for temporary card. You can use any other variable that you want, but this is basically easy to read. And what I want to do is I want to say temp card this is 10. So what this is doing basically is it's saying temporary card is equals to temporary card divided by 10. That way what is happening is, let's say we had a value anything it is, and if we were to divide it by 10, what it would do is it would eliminate this number 2. How would that happen? Because if you remember properly, if we were to say let's just say if we were to say if we were to do 104 divided by 10, it would give us 10.4, right? But if we were to use this divide value, what we would do is, if we were to use this divide sign, what it would give us is it would give us only 10, right? And if we wanted to get the 0.4, we would have to use a 104 and modulus 10, right? If we were to use this value, then we would get the 0.4 thingy, like basically the number 4, because that is the remainder. Okay, so with that logic, what we are doing is we are basically taking the entire value of the card which is entered by the user, and then we are dividing it by 10. By doing that, we are eliminating the last value. And similarly, we want to do this while the value of card is greater than 0, because that way what will happen is it will simply repeat the loop till the length is counted, because once it is 0, it would simply mean that we are here 0 point something, and that would mean all the digits in the number that is entered by the user, the card number, is calculated, right? So this is what it is doing. It is counting, it is helping us count the length of it. So the very first thing that we want to do is we want to use the simple logic as we read earlier. A Visa card uses either 13-digit number or 16-digit, right? MasterCard uses 16, and similarly American Express uses 15. So if the card number entered by the user is not equals to 13, 15 or 16, it is not valid. We can say that, right? Because it's already mentioned for the values that it is valid, for the number of digits that it is valid. So we can eliminate that thing here. And what we will do is, if length is not equal to, if you were to say double equals, it would mean like if it is equal to a given value, right? And by a exclamation mark and then a equals, we basically mean not equal. So if the length is not equals to 13, and let me copy this, and if the length is not equals to 15, and where is it, if the length is not equals to 16, it's not valid, right? So to do that, we want to like simply eliminate the program, stop the program, because we don't really want the program to be using any more resources, or basically the program does not really need to execute any more lines of code after this. So what we want to do is we want to printf invalid \n, done. And we also want to like basically end the program, so for that we will do return 0. The next logic that we want to check is Luhn's algorithm. I don't know how to pronounce it properly, but you get the idea. So what this algorithm says is, for a credit card number to be valid, it has to satisfy certain criteria, and that criteria is we have to start from the last, right? And we have to take the last second value and then the alternate values. So we take the last second and then we take the alternate value from the last, and then we take the other one, the other one, the other one, and what we want to do is we want to multiply each of those values. So 1 0 0 0 0 6 0 4, we want to multiply those values by 2. So once we have multiplied those values, after multiplying we would get these values, 2 12 8 of the corresponding multiplication values. And what we want to do is, after multiplying, we want to add them, right? But we don't want to add it like 2 plus 12 plus 8, that would be incorrect. If you look at the algorithm properly, it says to add the product's digits together, not the values of the product, but the digits. So what that means is we want to add 2 plus 0 0 blah 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 plus 1 plus 2, right? 12 is the value, but the digits of 12 are 1, 2, right? 1 and 2. Plus 0 plus 8, right? It has done the same thing here. And once we've done this, we want to add the value that comes after adding like the digits of the multiplication. We want to add the result 13 to the digits that were not multiplied by 2. So basically the last digit, that would be 4, then 0 0 dot 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 3, and then 0. We want to add those values to the value 13, right? And if the output that comes at the end, if it has a 0 at the end, right, then the card is legit, right? But there's also another thing that we have to make sure of, which is basically the numbers. We'll come to that later. In the very beginning, we want to check that the card is valid by using Luhn's algorithm. So what we want to do is, we already have the value of the card, right? So let's do this. First of all, I want to declare a few variables. Let's say int sum1 equals to 0, sum2 and 0, and then I also want to say total is equals to 0. After doing this, I want to declare a few more values, a few more variables. Those will be mod1. You'll see in a moment why I am declaring these variables. Mod1, mod2, similarly d1, d2. Okay, and then what I want to do is I want to update the value of temp card again to store the original value of card, because if you see properly in the previous loop, this loop, we were changing the value of temp card, right? So currently it's 0 point something, but if we assign it again to temp card, if we assign the value of card in temp card again, it will be like, it will get the original value, which will be useful in a moment. Once we've done this, we are going to use another do loop, and what we want to do is for the last and alternate values, and for that what we are going to do is we are going to say mod1 is equals to temp card, and this will give us the last digit, right? And what we want to do then, we want to add it, sum1 plus equals mod1, right? So if the user entered a really long value, let's say this, our current, like this part of the do while loop will take the number 4 and it will give it to us, right? And then we will store it in the variable called sum1. And then what we want to do is we want to remove that value from temp card, right? We want to take this entire number and then we want to remove the value 4, right? And we want to have just these many numbers. For that, it's fairly simple. We want to say temp card divided by equals 10. So what this will do is it will add a decimal value here. It will add a point. Because of that, 4 will become invalid because it's a long and not a floating point value, right? Long or integer, not a floating point value. So now we have only these many numbers, right? But if you look at it properly, it's the last second and we can use that value now. So first let's just do this for last second or second to last and alt values. We want to say mod 2 is equals to temp card modulus 10, right? This will give us the second to last value. And then what we want to do is we want to multiply it. So we could say mod 2 times equals to, right? After we've done this, what we want to do is we want to say d1. For example, let's say this was actually 6 times 2, which would give us 12. Now we want to add 1 and 2, right? We don't want to add like 12. So to do that, we will use d1 and d2. So d1 is going to equals mod 2 divided by 10, right? So what this will do is this will simply say 12. If the value was 6 times 2, it would do 12 divided by 10, which would give 1.2, right? And this value d1 will become 1, right? Because remember, d1 is a integer or a long. Long is basically like double the integer. I think it's more than that, but you get the idea, right? It will discard the value that comes after the decimal, right? So that is the function of d1. And similarly in d2 we want to store the remainder, which is 2. So mod 2 modulus 10, right? This will give us the remainder. And then what we want to do is we want to say sum2 is equals to sum2 plus d1 plus d2. So once this is done, what we want to make sure is for the first half of the loop we are eliminating the last digit, which we are in this line, right? Divided by equals to 10. Similarly for the second half, like we have already removed 4 in the first half, and for the second half we want to remove this, right? So that the next time this loop is repeated, we are starting here, right? To do that, we'll say to remove, we want to update the value of temp card by doing this, right? So what this will do is it will take the value that it received, which currently, or at least in the first loop, will be this, and then it will remove, like it will add a decimal here, which will basically discard the value that follows after it. So that would be, hold on, so that would make it like these many values. We want to do this while temp card is greater than 0, right? But once we've done this, what we want to do is we want to update the value of total, right? Remember, because what we were doing is this, we were adding like times 2 plus all of the remaining values which we have already stored. The 13 is stored in sum2, and all the other values, those were not multiplied by 2, are stored in sum1. And now to get the total, we want to add all of those values, right? Which is simply total is equals to sum1 plus sum2. And once we have this, we want to do this. We want to check whether or not the last digit of the value that we get by adding everything is a 0. If it's a 0, the card is legit. If it's not, the card is invalid, right? So we'll simply say if this is not equals to 0, what we want to do is we want to printf invalid, and then we want to return 0, because we simply want to like stop the program, right? But if that is not the case, we want the program to continue. And how do we want to do that? Now comes the next part of the program, which is basically utilizing these clues that are given. Every American Express card starts with a 34 or 37. Similarly, MasterCard starts with 51, 52, 53, 54, 55, right? There are other values as well, but we don't care about the other values or the other possibilities for this program. Similarly, every Visa card starts with a 4. Got it? Cool. Now, what we want to do is, we first want to take the input of the user, and then we want to get the first 2 values, because if you see properly, only the Visa has one condition, like it has to start with a 4, but for all of the other, we are checking the first 2 digits, right? So if we were able to get the first 2 digits, we would be able to use it for most of the cases, right? So which is basically the starting values or the starting 2 values, right? So what I'll do is I'll declare a variable, right? If you remember properly, we used a long to store the value of the card, right? Hold on, yeah, we used a long card. So here as well, we want to say long start is equals to card. And once we've done this, what we want to do is we want to do this. Okay, we want to say start, which is equal to the value of the card right now, is equals to start divided by 10, or we could say divided by equals to 10. We're using the same logic as earlier, divided by 10, but this time the condition is changed here in while, which is while the value of start is greater than or equals to 100, right? If it is greater than or equals to 100, we will have a 3-digit value. But if it's less than 100, which will be the case when this loop stops, then we would have either a 99 or a value less than that, which would basically be the first 2 digits, right? If we were to add a comment, we could say to get the starting 2 digits of the card. So once we have this, what we want to do is we want to begin using the conditions that we had. Let's start with Visa itself, because only Visa uses 13 digits. Let's start at 13, then we'll go to 15 and then to 16. So if we wanted to check for Visa, we will use a if condition. If the length is equals to 13, or if the length is equals to 16, which is the condition for Visa. If you see here, Visa uses 13 or 16 digits, right? And let me put this into a bracket. Either of these has to be true for a Visa, right? And similarly, what we also want to do is the starting value divided by 10 has to be equals to 4. So what this will check is, for example, if the value that it gave us, so if it was giving a 47, it could still be there's a chance that it could be a Visa number, right? Or a Visa card. So if this is the case, if these values, or basically if these conditions are satisfied, which is the length condition and then the condition of the starting values, if this is satisfied, we want to print Visa. If this is the case, it's Visa. If it's not the case, we want to check another possibility, which is American Express. The length has to be 15 and it has to start with a 34 or a 37, right? Let's just take the length. To do that, what we will say is, if the length is equals to 15 and or the starting value is equals to 34 or 37, make sure to put this condition, which is this or this, inside bracket, and that way it will make sure that the result of this entire logic is compared with the result of this logic, right? Because in the middle there's a different logic that we're using, the AND logic, right? Once you've done this, if this situation or condition is fulfilled, then we want to print MX. We don't want to print American Express, we want to print MX. The next thing that we want to do is we want to check for MasterCard. And for MasterCard, the length has to be of 16 digits and the starting values have to be greater than 50, 51, 52, 53, 54, 55, but less than 56, right? So to do that, what we will do is we'll check another case. If it's not a Visa, if it's not an MX, another possibility is it's a MasterCard, right? But there's yet another possibility that it does not belong to any of these categories, and in that case we want to print an invalid output, right? That is why I'm not just saying else it's a MasterCard, because it may or may not be the case, right? So we want to make sure that all the conditions are satisfied. So to do that, if the length is equals to 16, and if I'll put a bracket, and inside the bracket I'll say if the starting value is greater than 50, which would include all of these values, and if it is less than 56, if three conditions are satisfied, we can safely say it has to be all capital. If any of these conditions are not met, or if it is not a Visa, an MX or MasterCard, then what we want to do is we want to say else invalid, return 0. It's not necessary to do a return 0 here, but let's just do it. Let's check whether or not our program is correct. So we'll come towards the bottom, and here, correctness. I'll copy this entire thing, make credit. Okay, in line 69 we did not add a semicolon, right? So I'll clear this, make credit. Oh wow, it is because here we are just saying length plus plus, we are increasing the value by 1, but there has to be a starting value, right? Okay, let's clear it. Let's say make credit again. Now it works. If we wanted to check it for ourselves before using the code, we could just copy this. We could execute our program. That is weird. Okay, what I just realized is this line 22 is where we are making another mistake. We don't want to check this, right? Because the length of card is always going to be greater than 0, because we are updating the value of temp card, not of card, right? So I'll just copy this, I'll paste it here, and now hopefully, now I think it's going to work. All right, there we go. A lot of greens. That is great. See, silly mistakes. I initially forgot a semicolon, and then I realized that I forgot to initiate the value of length, right? And then I realized that I was updating card rather than temp card, right? These silly mistakes can actually give us scary results while executing the program. So don't worry if you make mistakes, that is totally normal, right? Once we've done this, before we submit, we want to check whether or not the style is correct. If you wanted, you could just copy this, paste it here, press enter, and then see the style changes that you need to make. But what I like to do is, I like to click here, style 50. Once I click here, it will show me all the suggestions or all the style suggestions, and I'll just say apply changes on the right up corner, and it will apply all the changes. Now it says looks good, which is great, all we need. And now let's submit this. To submit it, what we will do is we'll copy this command, how to submit, and then we'll paste it. We'll press enter, and we'll give it a minute or so, a few seconds actually. It will ask us whether or not are we sure to submit this program, by keeping in mind Harvard's academic policy or academic honesty policy of CS50. We are sure that we want to submit, so we'll say yes, and we'll press enter, and it will say it's submitted. You can see the results here. So I'll command click. If you're on Windows, you can say, or you can try control click to open it in a new tab, and as you can see, check 50 gave us 17 out of 17. So the program is correct, and it's styled properly as well, because 1 is the highest point that you can get for style. So we got the entire program, and it is correct. That is how you build the program, credit, and that is how you submit it. If you have any other questions related to this program or any other program up to this point, make sure to drop them in the comment section. And if this video was helpful in any way, consider subscribing and maybe dropping a comment or liking the video, because these videos take a lot of time and effort to make, and any support that you show to the channel will be really appreciated. Thank you so much. I'll see you in another video. See you. Bye.